In this video, I will explain how to do statistical tests such as correlation and regression in R program, and also how to make different type of plots or charts such as histogram, box plot, bar plot, bubble plot, and line graph. As mentioned in last video, that we can enter commands either in source panel or in console, and they are both same. And in this video I will be using console to give my commands because it creates a more user-friendly experience. The first test we are going to do is correlation test, and for this correlation test we will use data that determines correlation between income and happiness level, and this data is in Microsoft Excel. So we need to invoke required package to import and read data from Microsoft Excel. The first thing is to call in the required package, and for that require once the read Excel package has been called in, the next thing is to import data from Microsoft Excel and store it in a variable. Because this data is about income and happiness relationship, so I will create a variable happiness file, let's say. This is how we import a file from Excel: read underscore Excel, then a path of the file, which in my case is C users are SIF desktop composite, and it's very important that this extension is also mentioned. It's mandatory, and then because Excel file has multiple sheets, so it's very important to mention the name of sheet, and the name of sheet is income happiness, and it shows that our data has been successfully imported and it appears here. For correlation test, we use this command CORTEST, correlation test, and then name of file, that's happiness file, dollar sign, and then let's choose one variable, that's income, and then when by pressing dollar sign these options appear, it means data has been successfully incorporated, and then click enter, and that gives correlation results, and it shows that correlation is around 0.865 or 86.5%, which is a very strong correlation between income and happiness. And also p-value is also very small, that's 2.2 and exponent negative 16. It's very small value, which again means that this relationship is significant. P-value is very small. It means that we can say that null hypothesis is rejected. So null hypothesis in this case was that there is no correlation between income and happiness. Since p-value is less than 5, that's 0.05, it means we can say that the correlation that we observe in this sample can also be found in the population. In other words, there is a strong evidence that this correlation that we found here, it can also be found in the population from which this sample was taken. So it means there are two things of our interest here. One is correlation coefficient, and other thing is p-value. One value, that's correlation, it represents the extent which means how one variable changes with changes in other variable. And p-value, it means significant. Next, we will move to regression analysis, and for that we need to import another data. For regression analysis, the data that I'm using, that's about heart or heart diseases, and that's dependent variable, and independent variable are smoking and bikes. I have imported data from Excel file. Now let's very see quickly what's in our data, and because this is about heart disease, so I use a name heart file for this one. And it shows that we have these variable. Here is about heart disease, that's dependent variable, and independent variable are smoking and biking. For regression analysis, I will use this command, my regression. My regression is a vector or variable that will be storing our results, and LM stands for linear model, and then here is our dependent variable heart file, $sign heart disease, and then there is tilde sign, and that's followed by first independent variable, that's biking, plus a second independent variable, that's smoking, and then comma data, and here's the name of our data file. When you click enter, then our regression results will be stored in my regression variable, and in order to view them we will use this command summary my regression, and here are our results about regression analysis, and it shows here are some statistics: minimum, maximum, Q1, Q2, that's also called as median, and Q3. When we write a question for a regression analysis, we will write it like this way. This is intercept, which means a 14.98 minus 0.200 plus 0.17, and it also shows, first of all, intercept 14.98. It shows that when other, it is the value of y, that's heart disease, when other two independent variables, they are 0. And slope of biking is negative, which clearly shows that the more a person does biking, the lesser will be heart diseases. And the slope of smoking is positive, which means the more a person smokes, more will be chances of heart diseases. And when we will write an equation, it will be intercept 14.98 minus 0.200, which means the number of miles, whatever is the unit of biking, that will be multiplied by this one. So which means it will reduce our overall result of y variable, thus clearly showing that this has a negative impact. And this one, smoking, whatever is the unit of smoking, let's say if the unit of smoking is number of cigarettes, that will be multiplied by this one, and that will add to the intercept, and that will give a bigger answer, which means smoking, the greater the extent of smoking, the greater will be the chances of heart disease. There are two more things of our interest in this analysis. One thing is the value of adjusted R square, which is very high, 0.9795, that's almost 98%. And the other thing is that p values are very small. So for instance, you can see here they are very small. They are less than 5% or even less than 1%. So which mean that they have a significant effect, and the effect that we see in this sample, it can also be observed in the population from which this data was taken.